Welcome to the project demonstration of solar operated automatic refrigeration and heating system. So in this chamber, we are using this chamber consists of around 4.5 liters capacity. So this will getting cooling and heating, both will be done with help of the Peltier plate. So in this box we have attached the Peltier plate along with cooling fan. So this side is a cooling fan. So whenever we are cooling this side, then automatically the Peltier plate other side will getting heat up. So we need to dissipate that particular heat with help of this CP cooling fan. So this will get the power supply from this wire through this electromagnetic relay, and the supply is from this battery. So coming to the battery rating, so we are using 3.7 volts 2600 milliamp lithium ion batteries. In that 3 are in parallel, so we'll get 11.1 volt, and below also there is 11.1 volt 2600 milliamps. And when we are connecting these two sets in parallel, we will get 5200 milliampere per hour current along with 11.1 volt. So that is the main operating voltage for our microcontroller and relay and to our Peltier plate also. So the microcontroller need 5 volts power supply. To regulate the 11.1 volt to 5 volts, we are placing a 7805 voltage regulator, so which will take 11.1 and provide us a 5 volts DC output. So when we on the power supply to this cage through this switch, so they start reading input from the temperature sensor. We are using DS18B20 temperature sensor, which will continuously monitor the temperature from this Peltier plate. And here we can see the heating and cooling. So above is the cooling, below is the heating, and middle is the off for the system. So when you want to switching from the cooling to heat, then you should keep this in off mode at least of 10 minutes. Then this temperature will come to the room temperature, then you can go with the heating side. So now let us place this in cooling side. And coming to the charging section, so if you want to charge a battery from solar panel, just connect the solar panel at T or S slots in this manner. And after I make the connection, we can see the light indication as the battery is charging. So due to this low lighting on the solar panel, we are getting the low intensity from this. So when we place this solar panel under the full sunlight, we will get the full intensity. And the charging time, either from the solar panel or whenever sunlight is not available, you can charge this from the transformer. So just on the power supply to this transformer, which will step down the 230 volts AC to 12 volts of AC, and that is input to this battery pack for charging purpose. Either from the solar panel or transformer, you need to keep the battery charging only for 3 hours maximum, 2 hours minimum. So after that, switch off this charging, and while final kit demonstration, connect the solar panel. Because of this transformer is just our secondary source of charger to charge our battery whenever there is no sunlight is available. And now on the power supply to this kit. Just on that, welcome message displayed on the LCD screen, and the temperature will be displayed as the relay gets switched on. It's a cooling mode, so you can check the temperature will be slowly cool down to the cooling temperature from room temperature. So we can sense manually also. You can see the temperature is decreasing now. You can sense manually by placing your hand at this slot. At this slot, you will get the sensing of cooling also. You can see the temperature is decreasing now. So there is an indication for the battery low. So when the battery is low, then we can see this brightness of this light will be LCD will be comes down, and the kit keep on restarting. Instead of cooling this Peltier plates, it will get the restarts. You can see temperature decreases from 34 to 32 in less time only. Right.